screen on. All right, so let's write some more functions now. Okay, so let's write a few more functions here. I'm going to delete all this stuff so we can start fresh. Let's say that we want to work with some string manipulation stuff. So we want to maybe reverse a string, so have a string be backwards what it originally was, but not using any built-in function, instead actually writing the logic to it. So let's start off with something like that. So for example, I might have a function, I think that's for comment. I might have a function where I want like the string hello, and I want to turn it into OLLEH, something like that, and return it as a string in reverse. Okay, so we're going to go ahead and write a function that does this. We're going to say def reverse string. This guy will take in a string as a parameter. All right, now because strings are immutable, if we want to modify a string, we have to either convert it to a list. Now, we can build a new string, which is this guy in reverse. So we can build up a string through concatenation. So I can say answer is equal to the empty string. Okay, so the empty string is a building block for creating new strings. So we can build stuff onto the empty string. Then we can go through our old string, our original string, in reverse and concatenate each element onto the end of my answer. So you're going to see the same pattern we saw before, same for loop that goes from the end of a string to the beginning of a string. So for I in range, we're going to start off at the length of s minus 1, keep going as long as we are greater than -1, and step by -1 each time. So this is our stock loop that will go through every element of a string s in reverse. Each time through, I'm going to say answer is equal to answer concatenated with the current character that I'm looking at in s, which is s at position I. When this loop is done, I can go ahead and return answer. Now, notice something in Python that is different than most other programming languages, which is also a reason why I like Python as a first language. Python is very specific on working with indentation. So the things that belong to reverse string are all the things that are indented underneath reverse string. The things that belong to this for loop are the things that are indented under this for loop. So this return statement right here comes after the for loop. It's not part of that for loop because of how it's indented. Does that make sense? All right. Now, if we were working with another language, so for instance, let me show you the equivalent of this in Java, let's say. So we'll do vi test.java. So see a language like Java where we have these curly braces that indicate where things are in there. So I'm going to go ahead and just write reverse. So I'm going to say string answer is equal to the empty string for int I is equal to s dot length minus 1, I is greater than or equal to 0, I minus minus. Answer is equal to answer concatenated with s dot char at I. Then I'll return answer. Up here I'll say string s is equal to hello world. And then I'll say system.out.println reverse of s. All right, so there is our reverse program in Java. So let's go and look at this a little bit closer. So here's my reverse function in Python. Here's that same reverse function in Java. They look relatively similar, right? Not a whole bunch difference. But in Python, you have to indent this way. You have to have these things indented in a certain way so that you say certain things belong to other things. In a language like Java, I've chosen to write this in a reasonable way that looks good. Nothing keeps me from putting this entire thing on one ugly line So still gives you the right answer, but does my reverse function look as similar to Python anymore? So most of our modern programming languages rely on the programmer themselves to properly indent their code. And we can see that this is just gibberish. It made sense that I had it indented originally. This looks better when I go back here and I fix this up. I indent this guy. I indent that guy. So now it looks better again, right? Because I chose to make it look nicer. I chose to make it easier for a human being to read it. The computer doesn't care. All right. Now, a language like Python, though, part of its syntax deals with the indentation, which I think is very important for a beginning programmer where you're not used to indenting these things. You're not used to saying, here's the top of my function. I'm going to press enter. You might decide that, oh, it just makes sense for everything to just be left justified here. That program does something very different now. Go ahead.
Can I ask you about the for loop with -1, -1, -1?
Yep.
This point I'm not familiar with.
So this says start at the last. So when I say range, it says start at the last legal bucket of my string. Okay. So length of s -1 is the last legal place. You got that one?
Okay, yeah.
Good on that one. This says go all the way up to but not including -1. Because I'm going to be stepping backwards. So let's say my string had 5 elements in it. Okay. The last legal bucket is 4.
Yeah.
I'm going to be going from 4 to 3. So I'm taking a step of -1. Okay, so 4 to 3 to 2 to 1 to 0. And I include 0 because it's going to go up to but not including -1. So this says go to -1, not including -1. This is where to stop. This is how to count. Does that make sense?
Yeah.
All right. So Now, in any case, even though the exact same lines of code are written here now, this does something very different. Here's a function that has no lines of code associated with it because there's nothing indented underneath this function. Even though answer is the empty string is the very next line, it does not belong to this function. If I spread these things out, now they look less associated with each other, right? They are associated with each other at the same level now as they were just a second ago when they were just immediately underneath each other. In order for answer here to be part of that function, it has to be indented underneath it. Otherwise, it does not belong to the reverse string function.
Will it be global variable or?
It'll be a global variable. Yeah, in fact, this guy should probably give me an error because it's going to say that my function has no body. It would be my guess is what this guy's going to say. Yeah, indentation error expected in indented block. Because we are inside of a function and it expects me to have something indented for the body of that function. So now answer belongs to that function. Now this for loop belongs to that function. Now answer, this guy, belongs to this for loop, which belongs to this function. If I change the logic just a little bit and I go there, answer no longer belongs to this for loop. So it doesn't happen each time through this for loop. And if I come in here and I say return answer like this, it's still expecting an indentation issue because it said, hey, you wrote a for loop here. There should be a body to that. There should be something that belongs to that for loop that does the things associated with the for loop, at least one line. And I didn't have that. Does that make sense?
Yeah.
All right, so indentation in Python is extremely important, and this is proper indentation. Every programmer should indent their programs in a readable fashion like this, regardless of whether the language makes them do that or not. Okay? Python makes you do it, so that's why it's a good first language. Languages like Java, C, C++, they don't make you do it, but the second you have to go and look at somebody else's code, you want them to write readable code. All right? One of the other issues we run into today, and it's also why I like to use kind of do things by hand first. Like you noticed a few minutes ago, I was writing this Java program out here, and I used this text editor called VI. VI doesn't do any indenting for you. Most of our nice text editors that are out there, like we're using Atom here for Python, it's doing all those indenting things for me, or at least making it very convenient to indent. Well, a text editor like Notepad or VI, they're not doing that. I had to choose to press enter or press the space bar a few times to indent. If you get into the habit of doing that, you'll make less errors. One thing you may have noticed that I'll do is when I first wrote this function here, I'll just mimic it here. Whenever I first put a curly brace in a language that has curly braces, I immediately put the closing curly brace. And then I bounce up a line, and then I indent between it. That keeps me having my beginning and end of my function, and then everything else gets indented inside of it, even though this language does not require me to indent. That makes sense? It'll be a good habit to get into so that A, you can read your code 6 months from now when you go back and look at it for the first time. B, other people can read your code. And you'll also make less errors because of that. So don't ignore formatting. Python doesn't let you ignore formatting, so that's a good problem with Python. I say problem.
The time takes time to solve it at the beginning.
Sure.
For me, at the beginning, it takes me time to know how to fix it.
Yep.
Indentation.
Well, and I promise you, you're not alone. Most of the folks in this class had the same struggles. It was by intention, right? I gave you a relatively small problem to solve because that was going to feel hard for you. Because you were struggling with this new language and indentation and why the heck is this thing screaming at me? And I'm sure a couple of times you said, well, it has to be Python. Something's wrong with Python. It can't be me, right? I love that when you have students in class and they're trying to type along with what I'm doing and they say, I wrote exactly what you wrote. It's not working. Then they bring it up and it's like just almost exactly what I wrote. It's little, just slightly different than what I wrote. All right, so, but that's all part of the practice, right? You know, that's all part of this. All right, so I wrote this function here. Let's go and test reverse string real quick. Reverse string. We'll just give this guy hello. Save this guy. We should get hello in reverse. There's my hello in reverse. So we saw that same program now written in Java and Python. And at a glance, would you say they looked pretty similar? Here's the Java version of that guy compared to the Python version of that guy. You would probably recognize those guys on the street as at least being relatives. All right. So 2 very different languages. If we wrote that in C#, I wouldn't have to change a whole lot here to make this work in C#. You know, if I wrote the C# version of this S would be a lowercase s. This loop would look the same. This would change just S square bracket I. This would be a lowercase s. And this would be console.writeLine. Now that's C#. Same language, right? Swift wouldn't be very much different either. C and C++ would look a little bit different because strings don't know how long they are in those languages, so I'd have to pass a little bit extra stuff. But it'd still look pretty familiar. It wouldn't look drastically different than this. So that's covering programming languages from the late 60s all the way up to today. They all look the same because they all come from C. Yeah, so you have the same great-grandparent or whatever. It's all the same jazz. Okay. So that's reverse string if you want to start manipulating strings. What if, so now let's kind of use some fun tools that we had today. Let's say that I wanted to remove all the vowels from a string. So let's say I have the string hello, okay? And I want to have a function that will go through. Now remember, the vowels are A, E, I, O, and U. Those are vowels, okay? So I want to remove all the vowels from this guy. So I want to remove all the characters that are either in A, E, I, O, or U. So after I run this through my function, I should be left with HLL. That's hello with the vowels removed. Make sense? All right, so problem-solving approach here. I want to remove vowels from a string. Why might that be a problem for us? What do we know about strings? Strings are immutable. We can't change them. So if I want to remove the vowels from a string, what I'm really going to have to do is I'm going to have to create a new string and keep all the non-vowels. That make sense? So ultimately, I'm going to produce a new string that is the old string with the vowels removed, but I accomplish that by building a brand new string and only keeping the things that were not vowels as I go through there. Make sense? Okay. So we're going to say def remove vowels. This guy will take a string s as a parameter. Now, anybody have any suggestions on how I might pull that off using any of the magic tricks that I introduced today? We're definitely going to be building a brand new string, right? So there's several things here that we know we're going to need. So maybe we're going to have a string called answer, and that'll be the empty string. That's the guy we're going to build up with all the stuff that were not vowels in the original string. I'm definitely going to need to go through all the elements of my original string. correct? So I can say for I in range, and now we'll do a more traditional range thing. So I'll say, actually we can do a couple different things here. Let me show you something here real quick. So I'm going to say for I in range, I'm going to start off at 0. I'm going to go all the way up to the length of S, and then I'll step by 1. I'm just going to do a print S at bucket I here. So I'm not actually removing vowels yet. Okay, I'm just using it as my placeholder for right now. So I'll go ahead and I'll call my remove vowels. I'll pass this guy hello. We'll run this dude. There's my HELLO, 1 character per line. Make sense? Now, I'm going to change this loop here. I'm going to say for C in S, print C. First, let's see what it does. HELLO, HELLO. So they seem to do the identical thing, right? They do. The output in this particular case is identical. This is saying this variable C will equal each element of this collection. So this is called a for each loop. In a for each loop, this variable will, each time through the loop, will equal the next element in this collection. In this case, it's a string. A string is a collection of chars, of characters. So the first time through, C was H in our example. The second time through, C was E. Then it was L. Then it was L. Then it was O. That make sense? So I got the same outputs. What is the benefit of this guy compared to this guy? Why might I choose to use something like this versus this when this guy looks easier to write, correct? This is a little bit scary with this whole range stuff. Why might I want this over the shorter one that comes next? I have I. In the first one, I know if I'm looking at bucket 0 or bucket 1 or bucket 2 or bucket 3, that might be important to me, right? If whatever problem I'm solving requires that I know where I am in the string, I might need to know about I and then use that variable I to grab the character at a particular place in my string. The second one, this is just conveniently taking me through my string, but I don't know where I am in the string in terms of bucket 3 or bucket 4 or bucket 5. It's just taking me on through each element of the string. So even though in this particular case I'm getting identical output, from a problem-solving perspective, they're not giving me identical information. All right, but in this case, going through every element in the string is fine. So I can actually use my for each loop version of this guy. All right, so I'll go through every character in S. And now I want to ask the question, is the current guy, because we go back to our very first day, how do human beings solve problems? We remember stuff. I'm remembering something right here. I'm remembering something right here. We ask questions. I'm about to ask a question in here. And we do repetition. So here's my repetition. I'm going through every character in S. All right, and just if you could have called this elephant if you wanted to. I just named it C in there. So if I called it elephant up there, I have to call it elephant down there. That's just the name of a variable. Okay? So I want to go through every character in S. And each time through, I only want to keep that character if it is not a vowel. Okay? Now, right now, let's just keep every character to kind of prove what we're doing here. So I'm going to say answer is equal to answer concatenated with elephant. An elephant is my character in my string. That make sense? So elephant is a variable that will hold the next character in S. It's a poor variable name, but I just wanted to show you that you don't have to name it C. You can name it whatever you want. All right, and then in the end, I'll go ahead and return answer. And then I'll go ahead and print remove vowels of hello. So right now, remove vowels of hello is going to create a brand new answer. That's the empty string. It's going to go through every character in S, and it's going to go ahead and concatenate that onto answer. It's not paying attention to whether it's a vowel or not. It's just keeping everything. Okay, so this effectively is making a copy of S, and then returning that copy. So this guy's going to print out hello. I didn't change it at all. Here's my hello. All right, so now I only want to conditionally do this. I don't always want to concatenate on the character I'm currently looking at. I only want to do that if that character is not a vowel. How do I do that? Okay.
And then add a condition where if elephant is not involved, add elephant to the answer.
Okay. You are right. I don't want to use in yet, though. You're correct. You can do what you're saying, but I don't want to use the in trick yet. I could say something like, in fact, just to keep this shorter, I'm going to change this back to C.
Can you use split?
Huh?
Split.
Well, you could. Well, no, you wouldn't use split, because split will just split it on spaces. You could turn it into a list, but we want to specifically ask the question, is C a vowel? Now, we could write a little helper function here. We can say def is vowel, and that guy could take in a character as a parameter. And then we can say if C is equal to A, or C is equal to E, or C is equal to I, or C is equal to O, or C is equal to U, or the capital letter version of all those. All right, so let's just keep it like that. So if any of those is true, yeah, wrong language. But I'm allowed to. I'm headache and old, remember? All right, if any of those is true, then we're going to return true. Else we'll return, well, here, I'll throw an else in here. Else return false. So I'm going to verbosely ask the question, if C is an A or an E or an I or an O or a U, if it's any of those, go ahead and return true, otherwise return false. So then down here, I can say if is val passing in C is equal to false. There's a shorter way of writing that, but let me just write it out loud. I wonder, is false the right thing, or is it like pound? We'll see in a second. So if is val, when I'm looking at C, is false, if it's not a val, then I want to tack it onto my answer. But only if that condition is met. Okay? So now we'll go ahead and run this thing. That would work in Python 2. In Python 3, these are ORs. You spell out the word OR instead of the double things that's in C, C++, Java, Swift, and Python 2, as well as most other languages, but it's OR in this. Ultimately, it means the same thing. All right. Oh, false is not defined. So how is it? All caps, maybe? Python true literal. Capital F. There we go. So there's my HLL. All right, so now let's say I don't want to do this. I don't like that helper function. It worked. It's technically not complete. I would have to do the uppercase version of those. But we've learned a couple of magic tricks today. I want you to think about all the things that we learned, all those functions that we looked at today. Think of adding each of those into your little toolbox. Okay, so like over the years, through multiple trips to Home Depot or your favorite hardware store, you've acquired a collection of tools, right? And whenever something goes, breaks in the apartment or something like that, you have to solve those problems in terms of the tools that you have in your toolbox. Okay, so depending on how long you've been collecting tools and how interested you were in fixing things, you're going to have a very different set of tools than the guy next door might have, right? But it doesn't matter. Every problem you're going to personally solve, you're going to solve in terms of the tools that you have. Which means that sometimes you're going to solve things with duct tape and, I actually had an interesting experience with this. I had a couple of my Indian students this was a couple years ago. They were over at my place helping me hang a TV on my wall. And we didn't have the right size screw. And from an American mentality, I'm thinking, I'll just run to Home Depot and get the right screws. But because of where they came from, that wouldn't have been a convenient option. So they went and got some, I think floss, or some thin thread, and started building up the threads on the screw so that it would fit tightly. It was interesting. I mean, it makes sense after they did it, but I wouldn't have thought to do it. But just it's that kind of thing. They solved the problem in terms of the tools that they had available to them. They didn't have the right size screw. So rather than go out and find the right size screw, they made the right size screw is what they did. All right. So when we're solving problems in here, we have to solve them in terms of the tools we have available to us. There's a famous TV show. And if you haven't seen Star Wars or Star Trek, you haven't seen this one. How many of you, though, are familiar with a show called MacGyver? Have you heard MacGyver? So there's going to be two problems with this. One problem is they might not play it in your countries, but also it's an older show. It did just make a comeback, though. They made a reboot of it, like they've been doing. But the premise of this show, the premise of MacGyver, is every episode, this guy, MacGyver, would find himself in some sort of bad predicament. He was held captive somewhere or something like that. And he had to, find a way to escape. But he only had, 2 or 3 things available to him. So, one of the episodes, for example, he's, stuck in a garage somewhere. And he builds an airplane out of, a lawnmower and some, tarp. And, he has, 3 or 4 things that he builds an airplane with it. Which is kind of funny. If you there's another show on TV called Mythbusters. Have you heard of that show before? They've had an entire episode on there dedicated to MacGyver, where they go and they look at things that ridiculous things MacGyver did on a TV show and decide whether it could actually work. And I think they decided that the airplane out of the lawnmower would not have worked. You can't believe everything you see on TV. But the punchline of the show was this guy every episode had to solve some crazy problem using only the crap that he had around him. Okay? And we're in the same boat as programmers. All right? So today we've been introduced to several functions, right? So we're going to try to solve this problem using the functions that we've had available to us. Okay? Now I'm going to suggest to you which function we should use here. Okay, and then I want you to, I'm going to give everybody a minute to think about it. And then that way nobody just blurts out the answer right away. And we're going to see if you can come up with how we should solve this. It would be beneficial to us if we use the find function to solve the problem, to better ask this question. So I want to get rid of my isVal function, and instead I want to somehow use the find function for strings to ask this question more conveniently. Okay, so think about that for a minute, and then I'll ask who has a suggestion. So how do I ask to see if the current character C is a vowel using the find function? All right, so I'll pause this for a minute. All right, what do you think? Anybody have a suggestion of how we can use the find function to help us ask this question?
Can we create a list and store the vowels in the C?
Well, remind me, what does the find function do?
Gives the index if it finds the letter.
So it takes in a thing we're looking for, right? A character we're looking for, and it returns the index within the string of the first occurrence of that, or what does it return otherwise? Or it returns a -1. Remember earlier I mentioned that -1 thing is a pretty powerful tool because it allows us to search for things. All right, so you wanted to make a list of what?
Vowels.
Make a list of vowels or even a string of vowels, right? All right, so we'll go ahead and we'll just create something called vowels, and this will be A-E-I-O-U, A-E-I-O-U, so we have all the upper and lowercase vowels. And then right here, we'll ask the question, if vowels dot find, and I'm going to pass C into it, if that guy gives me a value of -1, that means C was not in vowels. Therefore, I should keep it. So I have some character. I'm going to look for it in my list of vowels. If it's not there, I'm going to get a -1. That means it's not a vowel. That means I should keep it if I only want to keep non-vowels. Does that make sense? So this little find function, even though you wouldn't have necessarily thought that this tool would have worked for a problem like this, it wouldn't have been the first thing that popped into your head. If we're like MacGyver and we have this toolbox that has 7 or 8 things in it, and we're looking in there and says, look, I'm not going to run to the store to buy a new tool. So I'm going to make this work. We're going to use this find tool and we're going to make it work for this. Does that make sense? All right, so this should give me same result. I just determined whether something I was looking at was a vowel or not in a little bit different way using the tool I had available to me. So there's my HLL. All right, I can change this guy to a different word if I want. Still pass it into my same function, and there's the non-vowel version of that. Now, what if I wanted to only keep the vowels in a string? So I want to remove everything that's not a vowel.
If not of definition.
So we'll copy most here. I'll actually copy most of this. So I have my vowels. If it's equal to -1, that means it wasn't in there. If it's greater than or equal to 0, that means it was in there. If find gives me some number that's not a -1, that means it found a vowel. That's a vowel. We'll keep it. Right? So when I search for C in my list of vowels, if it is found, that's what that says right there. If it returns a value greater than or equal to 0, that means it found this character in my collection of vowels. Therefore, it must be a vowel, and I will go ahead and keep it because I'm trying to remove non-vowels, which means I want to keep vowels. That make sense? All right. So if I call remove non-vowels on elephant, and now we should just have the vowel version of elephant. EEA. Those are all the vowels that are in elephant. That make sense? So little tiny change in what question we were asking here, and we got a very different result. This question says, if the thing I'm looking at was not a vowel, keep it. This thing says, if the thing I'm looking at is a vowel, keep it. And the only difference is what I checked the result to be. If the find function returned a -1, that means the thing I was looking for was not found. If the found function returns something other than a -1, so either greater than or equal to 0, or you had mentioned, we could have said not equal to -1. Something other than -1, which means it was not found. Will give me the same answer. Okay, so this little exclamation point thing there is not. Saying not equal to. That makes sense? Okay, let's. What I want to do next. Okay. So now I want to do a sorting. We're going to work with some lists a little bit first. Okay. So first of all, let's look at some list functions. So I'm going to come back to our book here. We'll go to lists. Here's list methods. So we can append things to a list. So we append a single element to a list. We can also extend one list with the contents of another list. We can also insert into a list at a specific position. All right, so let's look at a couple of those tools. Now remember the difference between a string, well, lists are mutable. That means we can change the contents of a list. Strings are immutable. Now, a list that contains a collection of characters is very similar to strings otherwise. But lists can contain collections of all sorts of things. For instance, we might want to have a list filled with random numbers. All right, but let's experiment with a couple of these toys here, these tools, so we can, it's like a free grab bag day at Home Depot. So I'll go ahead and we'll just go down here. We're going to create a L1 is going to be equal to the list 1, 2. Then we'll say L2 is equal to the list 3, 4. We'll go ahead and print out L1. And you'll notice that you can tell that something is a list when you see it printed because it uses this format for printing. Puts it in square brackets. Now I can print out L1 at bucket 0, which will give me the 1. There's the 1. So just like strings, lists are indexed from bucket 0 to bucket length -1. So this is a 2-bucket list. This is bucket 0. This is bucket 1. Length is 2. Last legal index is 1. This is going to give me bucket 1, which is going to be a 2. What if I say give me bucket 2? It's going to not be happy with me because I'm asking for an index that doesn't exist. Index out of range. Legal indexes are 0 and 1. I asked for bucket 2. Not going to fly. I can say give me the length of L1. And that should give me a 2. The number of elements in that array is 2. There's my 2. I could say L1.extend L2, which should effectively glue L2 onto the end of L1, so I should have the list 1, 2, 3, 4, and the length of that guy should be 4. Right? So I'm saying give me the length of this new list that was created by extending L1 with the contents of L2. What row? Just EXT? Extend.
And two square bracket.
Length should be in parentheses like this. Just take square brackets? No. Because this guy should be a list that I'm passing it. Let's just print out the list. L1, L2. Doesn't look like it has seen that function. Let me try something here. Yeah, that's the thing. All right, so extend, when I say L1, extend L2, this actually will replace the value of L1 with itself with L2 extended on it. So this guy does not actually return a value. He just does the magic. So this line right here will produce a new value for L1, which is the extended version of L1 with L2 tagged onto the end of it. So now when I printed out L1, it was 1, 2, 3, 4. And now I can print out the length of that guy, which should give me a 4. Make sense? So if I want to glue a couple of lists together, I can use extend that way. All right. We can append an element to a list. Okay, let's see, does that work the same way? It does. So same pattern. I can say L1 dot append a 5. And then I'll go ahead and print out L1. So I extended L1 first, so it should be 1, 2, 3, 4. Then I appended a 5, so it should be 1, 2, 3, 4, 5. So there's my appended value on the end of that. And notice it follows that same pattern where L1.append updates the call. This would be called the calling list. So this list is calling his append function, passing a 5, and it tacks on a 5 to the end of this list. This list is calling his extend function, which is taking L2 and tacking it on to the end of L1, tacking on the end of himself. Insert at a particular position. And it's actually insert before. So insert X into the list before the position you pass it. All right, so this example here, we're saying I want to insert before bucket 1 the value 1.7. So this was bucket 0, this was bucket 1, so the new bucket 1 is 1.7. So I can go ahead and in my code here, I can say something like L1 dot insert at bucket 0 a -1, which should give me, actually I can do a 0. That'll give me the list 0, 1, 2, 3, 4, 5. Because I inserted this 0 at position 0, or before the thing that's currently at position 0. There's 0, 1, 2, 3, 4, 5. All right, so this is me working with things in a list. Similarly, I can remove an element from a list. I can remove the first item from a list with that value. All right, and this guy is going, it looks like he boils down to the list. So if I print out L1 dot remove, and I say I want to remove a 4, it should boil down to the list that is everything but the 4. It's not. It's the same thing as before. So L1 dot remove 4 updates L1 to be everything it used to be with the first occurrence of 4 removed. So there's L1 after I've removed the 4. So there's everything but the 4. All right, so now we have this thing called pop. And pop is associated with something called a stack data structure, which we talk about actually in the next course. But pop removes the front of the list and returns it. All right, so if I come in here and I say print L1 dot pop, like that, and then I print L1. Here, let me print L1 beforehand as well. So I'll print out L1, which should be the 1, 2, 3, 5. Then I will pop from that, which should give me actually it'll be a 0, 1, 2, 3, 5. Then I'll print out L1 pop, that should be a 0. And then I'll print out the list again, which should be 1, 2, 3, 5, with the 0 removed, because I am popping the 0 off of my list, which does remove it from the list. So there's the original list. 0, 1, 2, 3, 5. Oh, actually, it's interesting. Pop is popping off the end. So 0, 1, 2, 3, 5. But when I popped, it actually popped the last element off the list, not bucket 0, which actually makes it work a little different than a stack does. Because stacks always pop from the top, would have been bucket 0. But that's fine. This is just the way it behaves. So now you know when you pop off of it, we're popping off the end of the list. So that means we remove the 5, which means that afterwards that 5 was no longer there.
Can we give the index value to the pop function?
Which index value? Oh, we can. Remove and return item at position. Yeah, you can say I want to pop a specific bucket from there. So I can say instead of pop there, I can say I want to pop bucket 1, which would be a 0, 1. That would remove the 1 from the list. So this says pop the element that lives at this bucket in that list and remove it. So there's the 1, the thing I removed from position 1, and it has been now removed. That makes sense? Okay, so now three random Import random, random int. Okay. So we're going to use a random number generator here. So at the top, I'm going to import something called random. And then down here, let's just do a little for loop for I in range 0 to 10. Print random dot, what's the rand int. So that should give me values between, here, I'll actually do it 0 to 10. That should give me values between 0 and 9. Let's see if that's the, so here's random numbers between 0 and 9, 10 of them. If I want more than 10, go back here, I'll just change it, let's say change it to 100. Give me 100 of those. So there's a 9, we should never see a 10 in there. Yeah, so it's, oh, we do see a 10, so it is inclusive. So when I say give me a random integer from 0 to 10, this is from 0 to 10 including a 10.
Why don't they just keep it consistent with like almost all of the methods? Because if we do a range, it's not including.
Yeah, and actually typically random number generators don't include this value.
Right.
So they do in this one. Deal. There's probably 5 other random number generators. Oh, very sad. All right. This threw a little fit. I need my Mountain Dew, right? Diet.
Yeah.
Go ahead.
I have a question.
Yep.
Now, you say for I in range from 0 to 100. Then when you print, now random this random 0 to 10.
Yeah, so
What that is on
this is doing something 100 times.
Okay.
So I'm doing a for loop. I'm repeating it for I. The first time through, I will be 0. Then it'll be 1. Then it'll be 2. Then it'll be 3, all the way up to 99.
Okay.
So I'm doing something 100 times. What am I doing? I'm printing out a random number between 0 and 10. 100 times.
Okay. Can I see the result, please?
Yep. So here's
Ah.
so here's 100 outputs,
Uh-huh.
and each output was something between 0 and 10. That make sense? All right. So I have a whole bunch of numbers. All right. Go ahead.
What if I want to move, I want to have the same random numbers again?
The identical random numbers again? Here, let's look. A lot of random number generators don't seed themselves. So here, the first 4 numbers were 5, 1, 8, 6. Let's just try to run this again.
I think we have to store
Yeah.
them in a variable.
Yeah, we would. So this is actually this is a good random number generator. Some random number generators will always generate the identical streaming of values unless you seed the number generator. This one gives you the same ones. But if you want to have the collection, you want to do something else with them, so you want to use them later in the program, we're going to have to store them. So we're going to go ahead and do that. We're going to put, let's say, 100 random numbers into a list. Okay? How do I do that? How do I create a list that has nothing in it and then fill it up with 100 random numbers?
Just an empty braces.
Okay, so we're gonna call this my random numbers, and that guy's gonna be like that.
Mm-hmm.
So the empty list. Okay, and then rather than printing my random numbers here, what am I gonna do?
My random numbers, append,
Insert.
dot append.
You could have also done insert at the length of it. It would have been kind of a nasty line to write, but you could have done it. It would do the same thing. So I'm going to append to my random numbers the result of generating a random number between 0 and 10. Okay? And just to give me a little bit bigger range here, I'm going to say 0 to 100. All right? So I'll fill it up with numbers between 0 and 100. What's the output of this program going to be?
Output from 0 to
List
so,
of 100.
Or we don't have print
List of 100.
Nothing.
because we don't have print function.
I never actually printed it. Now I'll print it and I'll see it in a list form. Okay? So this line is associated with this for loop. After this for loop has completely finished, will I get to this next line because of where it's indented. Okay? So there's my list of random numbers. That make sense? Okay.
Is it ever possible for it to print one number twice? Generate one number twice?
Well, it's definitely possible to generate one number twice. In fact, yeah, I'm sure we can find it in here pretty quickly.
Yeah, so,
Yeah. Yeah, especially if we did 100 numbers between 0 and 10. We get a lot of duplicates then, yeah. All right, so now, the next thing we're going to do, before we get too far ahead of ourselves and decide, you know what, maybe I'm going to use this sort function. Why should we use a built-in sort function when we can just write our own sort function? That's what the cool kids would do. They would write their own sort function.
yeah.
Right? All right, so let's take 10 minutes and we'll come back and do our final hour. So I got to go find new Mountain Dew.
So that's the only reason.
Well, no, because the timing will work out right then. So we'll have 1 hour left for the last part of class.
Okay. I'll accept that as an answer. I think I voted in motion.